Okay, so here is H9. I'm going to do two problems from the practice. All right, I'm going to do number 2 and number 4. Okay, so given this function, find all x values where f has an inflection point. Okay, I just had an idea. I should write something down. Okay, okay, let me write this down. Okay, so I'll write like this. Okay, situation, need. Okay, so we're going to look at two situations. All right, the situation is we have f of x. We want extrema sorry, I'm just thinking this. Extrema or increasing or decreasing. We need an f prime sign test. F prime number line sign test. Okay. All right, now, if we've got this situation, we have f of x, and we want a point of inflection, or knowing concave up or concave down, we need an f double prime number line sign test. Okay, so here's two situations. If you know f and you're looking for extrema or intervals of increase or decrease, you need an f prime number line sign test. But if you're asking for points of inflection or concave up or concave down, that's when you want to think of f double prime. Okay. So I'll try to go fast, guys. So given this function, find all x values where f has an inflection point. All right, inflection point. That's a point of inflection. We know f, we're being asked for a point of inflection. We need the f double prime number line sign test. So, guys, this works very much like the f prime number line sign test. Instead of finding the first derivative, you find the second derivative. So f prime of x is 4 6 x to the third minus 9x squared plus 16x. Okay, that's f prime. F double prime. What am I doing? I'm multiplying this by 3. Right, so it'd be 12 over 6 is 2. Okay, now we're going to have to find the parts where f double prime is 0, because we're looking for sign changes on f double prime. That's the big thing. If you're looking for a point of inflection, you're looking for, you could be looking for an extrema on f prime, but when we've got the equations in front of us, it's way, way easier to just be looking for a sign change. A sign change is way easier to look for than an extrema. So we're going to be looking for a sign change on f double prime, and that will indicate a point of inflection. Okay, so let me factor this and set it equal to 0, so I could take out a 2. X minus 8 minus 1. Okay, so that's f double prime. So when is this 0? Okay, so let me go, all right, so I'll go, oh my gosh, f double prime. Okay, so this, make sure you label the number line, guys. Okay, this is the f double prime number line. So x equals 1 and x equals 8. That's where f double prime is 0. Okay, now I've got to pick testing points. If 0 is in your interval, then you should choose it as a testing point. And then between 1 and 8, I guess I'll choose 2. And then beyond 8, I'll choose 9. Okay, so 2. All right, so for 0, this is positive, this is negative, that's negative. So that means that this whole interval, any number you plug in there, it's going to give you a positive f double prime. Let's plug in 2. That's always positive. And then this is negative, right? And that's positive. So that's going to give you a negative. And then here, I'll plug in 9. That's positive, positive, positive. Okay, so f double prime, we've got sign changes, guys, at both 1 and 8. So POIs at x equals 1 and x equals 8. Why? Because f double prime has a sign change. Okay, that's blurry. Okay, now, given this function, find all intervals on which f is concave down. Concave down. If they're asking you about concavity, concave up or concave down, you need the f double prime number line sign test. That means you find f double prime, you find its zeros, you put them on a number line, and then you pick testing points in all the intervals, and then from there you could tell whether f double prime is, you could tell f double prime's sign on those intervals. Okay, so first we got to take f prime. That's going to be negative 1/2 x to the 4th plus 9x squared. Negative 2x to the 3rd plus 18x. Okay, let me factor. I'll take out a negative 2x, x squared minus 9. Okay, so when we do this number line test, okay, take a look at each of these factors, guys, and ask yourself, when are these factors 0? Okay, so negative 2x, all right, so we'd have 0, negative 3, and positive 3. Okay, so, all right, so let me go up here. I'll just say equals 0 when x equals 0 and plus or minus 3. So that is what is going down here. Okay, so we're going to have negative 3, 0, and positive 3. Okay, so now I'm going to take this, okay, I'm going to choose testing points. All right, so let's do like negative 4, negative 1, 1, 4. I always make my testing points really small so that I don't confuse them with the actual like end points of the intervals. The testing points are just random numbers chosen within the interval. Okay, now let me take this and set it up like this. I'll go negative 2. I mean, you could do it differently, guys, but I'll go negative 2x, x plus 3, x minus 3. So I'm separating all the factors. All right, if I plug negative 4 in up here, this is always negative, that'll be negative, this'll be negative, and that'll be negative. Negative times a negative is a positive, negative times a negative is a positive. So really we've got 2 positives, that's a positive interval. Plugging in negative 1, that's always negative, that'll be negative, that'll be positive, that'll be negative. these two make a positive, these two make a negative. So really we've got a positive times a negative. That's a negative. And guys, sometimes the sign won't change from one interval to the next. So don't just assume. If you plug a 1 in, that's always negative. That'll be positive, that'll be positive, that'll be negative. Negative times positive times positive times negative. That is a positive because these would be make a negative, those would make a negative. Two negatives make a positive. Plugging in 4. Negative, positive, positive, positive. So that is a negative. Okay. Okay. I just wanted to say something, but then I don't think I will. All right, so we're asked when is F concave down? F is concave down when F double prime is negative. Okay. Okay, let me actually change this. I'll say F has points of inflection at, okay. And then down here, I'll say F is concave down on negative 3 to 0 union. That's an infinity. Union 3 to infinity. Okay.